Oh, yeah.
Okay, so employee name is a subset of the attribute, subset of the set. So what Tenali Raman ki
Today we have Dr. Toshib Diwan sir. Good morning, sir.
Good morning, sir.
Can start the session.
Okay, sir. Thank you. So, good morning, good afternoon, all. Last time we have seen the confusion matrix for binary. Today, we just look at the confusion matrix for multi-class classification. Okay, so similarly, this confusion matrix, it was a confusion matrix for binary classification. So two classes are there, like positive and negative. Okay. So it can be extended for three classes also. Like here you can see here three classes are there: apple, oranges, and mangoes. Okay. So these are the labeling true classes, and this is the prediction by the model. So horizontal lines are denoted by these prediction classes, and vertical lines are indicated with the help of this true classes. Okay. So this will be true positive. In earlier case, it was just true positive, but here it will be true positive for apple class. Okay, this two will be two classes is oranges and predicted as oranges. Okay, so this will be true positive for oranges. Similarly, this one will be true positive for mangoes. Okay. Can anybody tell what is the false positive for oranges? False positive for oranges. False positive means predicted as oranges, but that is false. So what is the prediction for oranges? Yeah, 1 and 3 is the correct answer. So this is the prediction for oranges, this horizontal line. So this 1 is false prediction, this 2 is true prediction, this 3 is false prediction. So total false for oranges is 1 plus 3, that is 4. Okay. The false positive for mangoes will be 3 plus 2, that is 5. Okay. What is false? for oranges, false negatives for oranges. Yeah, that is 10. 10 is correct. Okay. False negative means predicted as not oranges, but actually that were oranges. Okay. So this columns summation excluding this 2 will be the true negative. Okay. So this can be extended for more than 3 classes also. So it was a confusion matrix. Next we start with the deep neural networks. So it was just a general architecture of neural networks. This is input layer, these hidden layers are there, and finally this output layers. So it is a fully connected neural networks. Fully connected neural network means neuron in any particular layer is connected to all the neurons in the previous layer. Okay. In some of the literature, this input is not considered as an explicit layer, but in some literature you will find that input is also considered as a separate layer. So if input is considered as a separate layer, then total 4 layers are there in this neural network. And if input is not considered as a separate layer, then it is a 3-layer neural network, including this input layer. Now, if I want to find out the handwritten digit recognition problem, like suppose one image is given in the grayscale, and I just want to determine whether the image is for handwritten 1 or handwritten 2 or handwritten 3 or any other thing. Okay. Total how many possible outcomes are there? Total 10 outcomes are there. It may be handwritten 0, it may be handwritten 1, or it may be handwritten 9. What is the input provided to this problem? Input provided to this problem is a 2-dimensional image. Okay, it is a grayscale image, means it is just a black and white image. So basically there are 2 types of images, grayscale image and RGB image, colored images are there. So the depth of the grayscale image is 1 and the depth of the RGB image or colored image is 3. First channel is for red, second channel is for green, and third channel is for blue. So 28 cross 28 image is there, means 28 pixels are there horizontally and 28 pixels are there vertically. So total how many values are there? 28 multiplied by 28 means 784 values will be there. So this will be the value of first pixel of first row. This will be the value of second pixel of the first row, and so on. So similarly, this can be represented with the help of a vector of 784 values will be there. And this is hidden layer. So total, suppose we are taking 15 neurons in the hidden layer, and finally we are trying to predict the category for the output image. It's a 3-layer neural network. Similarly, we can see one more deep neural network here. 3 hidden layers are there. This is output layers, and this is finally hidden layers are there. Now, one intuition is there, like weight matrices. Weight matrices between this input layer and hidden layer. First hidden layer is represented with the help of W1. Okay. So weight matrices between this first hidden layer and second hidden layer is represented by W2 and so on. Okay. Each and every neuron is associated with one bias. So bias for this neuron will be different. Bias for this neuron will be different. What is the role of bias? It just take the weighted sum from the previous layer and add the bias, and after that it applies activation function. So this is the overall analogy of any neuron. Now we will see how this deep neural network came into picture. Suppose we take once again different example, like one image is given and we are just interested, image is a face image or not a face image. So okay, so it is just a binary classification. So we can say if output is 1, then the input image is face image, and if the output is 0, it means that the input image is not a face image. Okay, now we can divide the problem into several sub problems. How one problem can be divided into several sub problems? So what are the characteristics or what are the features of a face? A face can be characterized by a left eye, by a right eye. Is there a nose in the middle? So we will split the problem. This problem, is there a face? This problem is broken up into several sub problems. So this is the first sub problem. Is there an eye in the top left? Second problem, second sub problem, is there an eye in the top right? Is there a nose in the middle? Is there a mouth at the bottom? And is there hair on the top? Okay. And this is the input image that is provided in terms of a vector. Now, just correlate this in terms of a neuron. network. So this is the input layer, this will become your hidden layer, and this will become your output layer. So total how many layers are there? Total 3 layers are there. Now we will say if the output of this particular subproblem is yes, if the output of second subproblem is also yes, and moreover we can say when the output of all the subproblems is yes, on the basis of these 5 yes, we can say that the input image that we have provided is a face image. Now see, consider this subproblem. There an eye in the top left. Okay. Now we cannot directly determine whether there is an eye in the top left or not. We need to break this subproblem into further subproblems. Okay. Now what are the characteristics of an eye? Is there an eye in the top left? It was a subproblem in the previous slide. Okay. We are breaking this problem into several subproblems. Now characteristics of an eye will be eyebrows, eyelashes, and iris. Okay, so we will break this subproblem into 3 subproblems. So this is the first subproblem, second subproblem, third subproblem. We will take the output of each and every subproblem, and on the basis of result of these 3, we will conclude whether the input or whether there is an eye in the left or not. Is it fine? So ultimately what we are doing, this problem, this first subproblem is broken up into 3 subproblems. So in neural network analogy, we are inserting another layer here. So the 3-layer neural network is getting transformed to 4-layer neural network. Okay. Now, it was a subproblem. Is there an eyebrow? So we cannot determine directly whether there is an eyebrow or not. We need to find the features of an eyebrow. This subproblem is broken up into several subproblems. If this subproblem is broken up into several subproblems, it means that we are inserting one more layer of neural network here. So when a subproblem is broken up into several subproblems, it means that layers are getting inserted in the neural network and the neural network is becoming deeper and deeper. Is it clear? Okay, one question is there, how to determine how many hidden layer for a specific problem. Okay, so generally we can take suppose if we find out, or if we take an application or a problem to determine whether the handwritten digit problem, so basically we need to determine that how many features that we are interested in. So on the basis of those many features, we can decide the number of layers in the deep neural networks. Okay, generally 15 layers are common for any normal problems. If the problem size is large, then we need to define the more layers. We will see one example in which the things will get clear. Okay, so basically there are 2 types of neural network: feed forward neural network and recurrent neural network. In feed forward neural network, the information is propagated in only single direction, means the information is always fed forward. No self loop is, no information is back propagated to the previous cell. So that is the feed forward neural network. And the second category is recurrent neural network. Recurrent neural network means output of one neuron is back propagated to the previous cell so that they can adjust weight. Okay. Now, just look at this Venn diagram which determines the relationship between AI, ML and DL. So AI is a program that can sense, reason, act. However, machine learning is a set of algorithms whose performance improves as they expose to more data over time. And deep learning is a subset of ML, which is multi-layered neural network that learns from vast amount of data. So only one thing that is very important here, when we move from AI to ML, or when we jump from ML to DL, the size of the data is getting increased. It means that deep learning or deep algorithms is applicable or is only when the data size is very large. If the data size is not that much large, then we can go for simple ML algorithm like support vector machine or logistic regression. If the data size is very small, then we can go for plain AI algorithm. Okay, it completely depends on the size of the data that you are having. If data size is very large, then you can go for deep learning algorithm. If the data size is not very large, then there is no need of applying deep learning algorithms. You will not get that much performance in deep neural networks. So three things are there behind the success of deep learning. First one is the huge amount of data that is generated day by day. Okay, so various sources are there from which the data is generated, and we have to handle those much amount of data. Second thing, we are having the powerful and enhanced computational capability. We are having the multi-processor system. We are having the multi computers, or we are having the accelerators like NVIDIA GPUs are there. So the computational power of these machines are very large. So two things are there. Data is very large, and for processing those data, the machines are very powerful. Okay, and the success stories of deep learning in various domains such as wind forecasting, such as sarcasm detection, NLP, computer vision. So deep learning is performing very well in all of these domains. Okay, so we can incorporate the deep learning in the new domains also. Just as in statistics, we can list some data like this MS COCO data set. The data set size is 19 GB. However, if we go for ImageNet, this was the previous version of ImageNet 1K, and this is the later version of ImageNet 22K. The data set, the ImageNet size is 180 GB. However, the later version size is a few terabyte, and in industry, the data set size is much larger. Okay, and see the deep neural network. It is not a case of 3-4 layer neural network. We are having 100 to 200 layers in the deep neural network. If you are having 100 to 200 layers in the deep neural network, then just imagine how many parameters will be there. Parameters means the weight and biases. How many parameters will be associated? How many biases will be there? Okay, we need to find the values of each and every parameter such that we need to reach to the local minima or global minima of that particular neural network. Then the faster prototype. It is not like the case that you just construct a deep neural network. Training of that deep neural network, it takes a huge amount of time. Sometimes it takes a week also. If you plot these between the data size and model performance, so you can just note here if the data size is very small, like here, then this traditional ML algorithm, this red line, the performance of these ML algorithm is far better as compared to the large neural network. Okay, when the data set size is very large, here you can see data set size is very large, then only you will get the model performance better as compared to the small neural network, medium neural network, or any traditional ML algorithm such as support machine or logistic regression. Deep learning is getting introduced in various fields like digit recognition, object classification, segmentation, then image captioning, gameplay AI, neural computing. Okay, so there are various kinds of deep models such as convolutional neural network, recurrent neural network. Then the architectural variants are there, means we just propose some architectural variants so that we can remove the drawback of existing in the recurrent neural network, such as LSTM, long short-term memory, gated recurrent unit. Some deep belief networks are there, autoencoders, generative adversarial network. So these are the various deep models. Okay, so today we just cover this convolutional neural networks. We'll look at this, what is convolutional neural network, what are the different operations that can be performed by each and every layer of CNN, what is the applications, how the parameters are calculated in CNN, and finally one example is taken. Convolutional neural network, it is a deep neural network designed for automatic feature extraction or classifier. Before the introduction of CNN, in earlier scenario, we need to manually determine that which features that we are interested in. After that feature selection, we need to extract those features. But this is not the case in case of CNN. In CNN, it automatically captures the important features by applying the convolutional filters. Okay. Generally, it was applicable for image data, but nowadays it is applicable for higher dimensional also. And it is easier to train and test. The basic difference between the CNN and deep neural network is that in deep neural network, a neuron is connected to all the neurons in the previous layer. But in CNN, a neuron is connected to only a part of the previous region. So there are various applications of CNN, but I have listed only two here, such as computer vision. In computer vision, it is very popular in image classification, image recognition, and object detection. In second, it is applicable in natural language processing, such as finding the sentiment analysis, emotion detection, sarcasm detection. Sentiment analysis means we just find out whether the sentence given to you is positive or negative or neutral. Okay. Then emotion detection means extracting the inherent emotions with that particular sentence, whether joy is associated, whether sorrow is associated, or disgust is associated. Okay. What is the emotion associated with that particular sentence? Extraction of that emotion is known as emotion detection. The third category is detection. Sarcasm detection is nothing but actually the sentence looks positive, but some inherent negativity in terms of taunt or in terms of some negative comments are associated with that particular sentence. We can give one example. The movie is so good that we left in 1 hour only. Okay, so the sentence is looking positive, but actually the inherent negativity is associated with that particular sentence. So this is the general architecture of any CNN model. Okay, so basically, suppose one image is given. So this is the neuron. Here we can see this neuron is connected to only region of the previous. So this is known as convolutional layer. Finally, this convolutional layers is followed by some pooling layer. So we reduce the size of this with the help of this pooling layer. So convolutional and pooling, this complete is nothing but one unit. After that, second convolutional pooling. After that, some flatten. Then some fully connected layers are there. And finally, this is the softmax for classification, whether the input image is car image or whether the input image is truck or van or any other category. Okay. So the problem is two parts. The first one is feature learning and the second one is classification. So the feature learning is done with the help of convolutional layer and the classification is done with the help of fully connected layers are there. Okay, so this convolutional operation extract the feature followed by the pooling. We will see what is convolutional layer, how it is computed, what is ReLU, what do you mean by pooling, what are the types of pooling in the subsequent slides. This is another example where CNN can be applied. It is a handwritten digit. Okay, we are applying some convolutional operation. So this is the first convolution operation. After that, for reducing the size, we are applying second convolution operation. Sorry, this pooling is applied. After that, another convolution operation. So this is the first convolution operation. This is the second convolution operation. A convolution operation is followed by max pooling. It is optional. You can apply max pooling or you cannot apply. So this is first convolution layer, this is second convolutional layer, followed by some fully connected layers are there. And finally, we are determining whether the input image is 0 or whether the input image is 1 or any other. Okay. Then, what is the general architecture if we write in terms of equations? So see, some convolutional layers are there. So this is the input. Some convolutional layers are there. The neuron present in the convolutional layer is activated with the help of ReLU, that is rectified linear unit. Generally, activation function used here is ReLU. You can use any other activation functions also. So this convolutional followed by ReLU, this architecture is repeated I times. Okay, followed by some pooling layers are there. We can see here pooling layer is optional. So this entire architecture, which convolutional followed by pooling, this architecture is repeated j times. So here we can see convolutional followed by pooling. This architecture is repeated 2 times here in this figure. So this is the first time and this is the second time. After that, some fully connected layers are there. So these fully connected layers are also activated with the help of ReLU. This is repeated to A times, and finally some fully connected layers are there which is repeated L times. Here I, J, A and L, these are integers. You can also see one difference. Some fully connected layers are activated with the help of ReLU, but this is not mandatory. Here we can see some fully connected layers are there, which is not required any activation. So it depends on the output that we want. Okay. Here we can see the convolutional layers are activated with the help of activation function, but in pooling, no activation function is required. Pooling is just a reduction of this input size. It is also known as downsampling. Now we will see the layer one by one. So first layer is convolutional layer, then second layer is pooling layer. Another layers are there like fully connected layers. Fully connected layer is also known as dense layer. And for the activation of this neuron, we can use nonlinear activation function. ReLU is used here. So we see the first one, that is convolutional layer. Convolutional layer is just what we can say if some part of the input is there and some weights are associated. So we just multiply these weights with the inputs and we compute the summation of each and every result. That is nothing but the convolution operation. So what does it mean? A filter is applied to a part of the input. Filter of weights is applied to a part of the input and element wise multiplications are performed. You can compute the summation of that and it is nothing but the output of that convolution operation. After that, that filter is shifted or that filter is revolving over the input and then you can compute the entire output of the convolution operation. So operation that basically takes two input. The first one is the input image or second one is the filter or more specifically we can say a weight matrices. It computes the output of a neuron that are connected to a local region in the input. Each a dot product between their weight and a small region that they are connected to in the input volume. The basic task of the convolution operation is extracting the features and it convert an input volume to an output volume. Before jumping to the convolutional layer, some terminologies are there that should be clear. Filter, it is also known as kernel or it is also known as receptive fields. Second one is stride. Stride is nothing but the by which we slide the filter over the input volume. Padding, whether the padding of zeros is applied on the input or not. If padding is equal to valid, it means that no padding is applied. If padding is equal to same, it means that we want that input and output should be of same size. And the most important thing is that number of parameters. How many parameters are associated with that convolution operation? We will see one complete example for the calculation of parameters. So this is the in which you are applying a filter over the input volume. So see what is happening over here. Before going to this, we can see this animation. What is the size of input? So actually this will be a pure interactive session. After that, we will take one exercise in which you will be computing the number of parameters. Okay, tell me what is the size of input? Size of input is 5 cross 5. Yeah, 5 cross 5 is the size of input. This 5 and this 5. Okay. What is the size of filter that we are applying? Size of filter that we filter is nothing but the weight matrices. Okay. So size of filter is nothing but this. Okay. So this filter, same filter is there. The size of this filter is 3 cross 3. What is that filter? That filter is this 1, 0, 1, 0 and then 1, 0, 1. This filter is revolving over the input. First, this filter is applied on this region. Okay. You perform the element wise multiplication and then you compute 4. After that, you shift the position to the right and then you compute 3. Finally, you shift the filter by one position, then you compute 4. After that, this filter is shifted downward and you come to this region and then you compute this 2. Is it clear? Here, what is the value of stride? Yeah, stride is equal to 1 because it is shifted by one position right, one position right. Okay, one question is there, how to choose the filter size and the elements of filters. So generally it depends on the input image. Suppose the input image is of 28 cross 28. So generally we can take the first filter as 5 cross 5 filters are there. So we can generally apply multiple filters. So one filter may be applied for detection of vertical edge. Another filter may be applied for detection of horizontal edge. Okay. So we will come to the previous slide. So here this was the input image and on which we are applying this filter. So finally you will be generating this output image. So see, just consider here the stride is 1. What is the width of input? What is the width of input? The width of input is, yeah, the width of input is 7. Input is 7, height of input is also 7. What is the width of filter? Width of filter is 3. Now you tell me what is the width of output that you are getting? What is the width of output that you are getting? Width of output is 5. It means that it is applied on this region first, after that it is applied on this region, finally this region, after that this fourth region, and finally this is the fifth region. So can we establish formula for computing the width of the output? So width of the input minus filter width plus 1. Is it width of the output is equal to width of the input minus filter width plus 1. So this will become 7 minus 3 plus 1. So that is 5. Is it clear? Actually, we will determine the generalized formula, but see how this formula can be established. So that should be clear. Okay. What is the stride here? Stride is equal to 1. So if the stride is 2, will it affect output volume? If the stride is 2, will it affect the output volume or not? It is that you are applying on this region first. After that, it is not. You shifted by 2. After that, you are applying on this region. So it depends on the stride also. So this is the formula for getting the output. So this weight is multiplied by this input in a 2-dimensional, and this weight is multiplied by this input in a 1-dimensional input. So there are two equations. So the first equation is related to 1-dimensional input and a single vector filter that is applied. In the second case, you are taking the 2-dimensional input and 2-dimensional filter is applied on this. So this we have already seen how the filter is shifted over the input and how you are computing this output. Now we need to see some other thing like spatial arrangement. The hyperparameter that control the size of the output volume. So 4 things are there that affect the size of the output volume. Okay, one question is there. If stride is 2, then output is 3 plus 3 in the previous example. So see, if the stride is 2, then first you apply on this. After that, you apply on this field, this region, and then it is shifted by 1 position, and then it is applied to this region. Okay. So total how many entries are there? So 3 entries will be there. So first, second, and third. After that, it is shifted by 2 position downward. So you just come here on this region. So the output will be 3 cross 3. Yeah, physical significance of choosing the filter size, it depends on the input that you are having. Suppose you are predicting or you are trying to build a neural network such that you want that whether the image is a dog image or not, it depends on how many objects are associated with one image. So it may be there like in one image, generally if your data set is like that in which multiple images are there. So if multiple images are there, then your filter size should be small. And if some images are there in which single image is there in that particular image, in that particular case, filter size should be large. So it depends, or you need to first analyze the data. On the analysis of these data, we can determine filter size, the number of filters, and so on. Okay, so the spatial extent, it means that filter size that we are applying. Second one, how many filters we are applying. Okay, this is the most important thing. The stride by which we slide the filter and zero padding, whether we are applying zero padding or not. Now see, padding is nothing but the we just put the some zeros on the boundaries of the input such that we fit the filter on the input volume. So there are basically two types of paddings. One is valid, another one is not valid. See here, if you are considering the valid padding, so if the stride is 3, now what will happen when the stride is 3 in this case? First you apply filter here, okay, you will get this entire region, then you compute the first entry. After that stride is 3, then you shift it by 3 position, then you come here, okay, then you compute another thing, another entity, then you shift it one more time. If you shift it one more time, then you just come here and some images are or some input is not there. It means that this region, this region is not considered the convolution operation. So this region is not the valid region for the convolution operation when we consider stride is equal to. When we fix stride is equal to valid, it means that if you get the entire picture of the input on which you can apply filter, only when you apply the filter, after that, if the portion is not complete, you just discard that portion, and discarding that portion is nothing but the padding is equal to valid. Otherwise, what we can do, we can apply some zero paddings. So zeros are padded here. After that, one more layer is padded of one more layer of zero is padded, and then you apply the filter. Okay, that is what is zero padding. In what we will do, drop the part of the image where the filter did not fit. This is called a valid padding. So if valid part is there, then we apply, otherwise we will not apply. This is the meaning of, this is the simple meaning of valid padding. Ultimately, see what is happening over here. One input image is there. How many filters we are applying here? How many filters we are applying in this animation? See, the first filter, that is this red filter is applied and you are generating this feature. Yes, 2 is correct answer. After that, you are applying the second filter, that is that green filter, and you are generating the second feature map. You may apply a third filter, you may generate another map, you may apply a fourth filter, you may generate the another feature map. What is the reason or what is the logic behind applying multiple filters? So it may be there like one filter is applied for detection of horizontal edge, another filter may be used for detecting the vertical edge, third filter may be used for detection of a circle, fourth filter may be used for detection of any other shape. Is it fine? The logic for applying multiple filters. Two types of convolutional layers are there. First, initial convolutional layer and later convolutional layer. So two types of features are also there, like low level features and high level features. So initial convolutional layers are responsible for extracting the low level features such as vertical edge or horizontal edge. Okay. And later convolutional layers are responsible for detecting the high level features, like with the help of horizontal edge, vertical edge, you can draw a circle, or you can draw a rectangle. So initial convolutional layer are responsible for extracting the horizontal edge or vertical edge. Later convolutional layer are responsible for extracting the rectangular shape or square shape. Okay. So in generally, low level features are extracted by initial convolutional layer, and high level features are extracted with the help of later convolutional layers. Some other filters are there. One question was there that how can we decide the filters? So basically, standard filters are also there. Like if you are interested in determining the identity, so this is the 3x3 filter is there. If you are interested in determining the age in the input, so these three standard filters are there. We can use any one of the filter. If you want to detect the sharpen, then this filter can be used. Okay, so these are some of the standard filter, but it is not always the case that you need this filter. Okay, model train and eventually it learn these filters, and later on you can start the fine tuning of the model. Now in this example, most of the thing will get clear. What is the input volume here? Volume is a 6 cross 6 cross 3. Width is also 6, and what is the depth? Depth is 3. So depth is 3, it means that it is which image? It is an RGB image. It is RGB image. How many filters we are applying over here? How many filters we are applying? Yeah, 2 filters we are applying. Okay. Now we need to compute the weight matrices, or we need to compute the parameters. That is how many weights are associated and how many bias will be associated. Now see, how many channels are there in input? How many channels are there in the input? 3 channels are there. Okay. So how many channels will be there in filter? 3 channels will be there. So this is the weight corresponding to first channel. It means that this 1 is going to get multiplied by this 4. 0 is going to get multiplied by 9. This minus 1 is going to get multiplied by 2. Is it clear? Okay. So the first, this matrix, first weight matrix is get multiplied with this first one. This second weight matrix is get multiplied with the second one. Third weight matrix, sorry, this third weight matrix is get multiplied with the third channel of the input. Finally, total how many entries are there? Total 27 entries are there. Okay. So if you perform multiplication between 1 and 4, 1 entry. If you perform multiplication between 0 and 9, second entry. So how many entries are generated by first layer? 9. How many entries are generated by second layer? Once again 9 entries. And then for last layer 9 entries. So total how many multiplication entries are there? 27 entries are there. So we sum all these 27 entries, and after summing we add the bias. Single bias is added, and then you generate the first entry of the result. You just look at the cursor. Is it clear? After that, this filter is shifted by one position right. It means that now this filter, this entire filter 1 is applied on this region. Which region? 925, 624 and 454. This filter is applied on this region. Then you compute the second entry of the first row. Okay, then this filter is shifted by one position. It is applied on this region. 258, 240, 545. Okay, you compute the third entry of the result. Okay, after that this filter is shifted by one position. Then you apply filter here, 583, 403, 452. You compute the last entry. Okay, complete first row is computed. This first row is completely computed. After that this filter is shifted by one position downward. Then you apply 562, 245 and 565. Same filter is applied. Then you compute the first entry of the second row. Is the computation clear? Any doubt in this computation? Okay, I am repeating this once again. See, depth of the input is 3. Depth of the input is 3. So depth of the filter will also be 3. Depth of the input is equal to depth of the filter. It means that in the previous slide here, see, what is the depth of input here? Depth of input? No, depth of input is 1. Yeah, depth of input is 1 here. In this also depth of input is 1. Okay. But in this example, depth of input is 3. That's why depth of filter is also 3. Is it clear? Okay. Now, this first weight matrix is multiplied with this first channel. This second weight matrix is multiplied with the second channel. Third weight matrix is multiplied with the third channel, and all 27 entries will be summed up. And all 27 entries will be summed up, and finally one bias is added. Then you compute this. Is it clear? Now, what is the depth of output here? Just look at this on which I'm moving the cursor. What is the depth of output? This region. No, depth of output is 1. Depth of output is 1. Width of output is 4. Height of output is 4. But what is the depth? Depth of input is 1. Is it clear? Okay. So, this was the result of applying first filter on the. Now, similarly, if I apply a second filter, so this is my second filter. Once again, how many channels are there in the filter? 3 channels are there. So this weight matrix is for first channel. This second weight matrix is for the second channel. This third weight matrix is for the third channel. And when we apply filter 2 on this input, then you will get this result. Okay. There, this first filter is determining the horizontal edge. The second filter is determining the vertical edge. Now see, this is the output of applying first filter on the input. This is the output of applying second filter on the input. So these outputs are cascaded in the Z direction. Now you tell me, this is the final output. What is the depth of final output? What is the depth of output? Depth of final output is 2. Can anybody tell why depth of output 2? Why depth of, yeah, kernel is equal to, no, this is equal to depth of output is equal to number of filters. Here see how many filters are applying. How many filters we are applying here? 2 filters we are applying. Okay. So the depth of the output is 2. If we apply 10 filters, then what will be the depth of output? Yeah. If we apply 10 filters, then the depth of the output is 10. It is that the output that is getting generated by applying this filter, this is cascaded in the Z direction. This is cascaded in the Z direction. Now just compute the number of parameters. Now you tell me first, how many parameters are associated with filter 1? How many parameters are associated with filter 1? 27 is one option. 27. Is there any other option? 9. Any other? 3. Okay, just let me explain this. So, what is the definition of parameter? What is the definition of parameter? Parameter is nothing but the weight plus bias. Parameter is nothing but the weight and bias. Okay, so if we consider this filter 1, okay, how many channels are there in this filter? How many channels are there in this filter? 3 channels are there. So, for first channel, how many weight matrix? How many weights are there? So this is the first channel. How many weights are associated with first channel? 9. So total, how many weights will be associated with all 3 channels? 27. Okay, so 27 weights plus 1 bias. So how many parameters will be associated? 28 is the final answer. 27 weights plus 1 bias. 27 weights plus 1 bias. So total 28. No, it is not 27 plus 3. First we add all this. First we add all this thing, and after that single bias is associated with this filter. With one filter, only one bias. Bias is independent of the number of channel of the filter. Okay, so single bias is there. Now you tell me how many parameters are there with us? How many parameters are associated with one filter? 28. How many filters we are applying here? How many filters we are applying? 2 filters we are applying. So total how many parameters will be there? 2 multiplied by 28. So it means that 56 parameters are associated with this complete convolution operation. Yeah, 56 is the correct answer. Okay, if 6 are clear, then we can take one exercise on the basis of this. Before jumping to that exercise, we just look at the pooling and what are the different types of pooling. Pooling layer is responsible for reducing the spatial extent. Basically, see what is the intuition behind pooling. So we can extract the dominating features. Like suppose 4 values are there. So in which 4 values, in among those 4 values, suppose one value is very high. It means value is corresponding to the features which dominates the other features. So what is our aim? Our aim is to extract the dominating features and to omit the non-dominating features. So it is also known as downsampling. It is also known as downsampling. Yeah, okay, one question is there. Which layer will extract which features? So basically, see, it depends on the weight initialization. So generally, weight initialization are done by different techniques of the filters. We start from any particular point and weight is getting converged in that direction such that you reduce the loss function. Okay. So it might be there, suppose you are applying 6 filters, then one filter will be doing some different task, another filter will be doing some different task, third filter will be doing some different task. It depends on the input and output because we are providing both of this. We are providing input also and we are providing the label also. Yeah, it is for different. Each filter is different. Each filter might be for different features. Like one filter may be for extracting feature 1, another filter may be for extracting feature 2, like this. Yeah, it is also depend on the specific problems. Okay, so in pooling, basically 2 types of poolings are there, max pooling and average pooling. In max pooling, we just take the maximum and we neglect all the values. In average pooling, we take the average. Okay, basically it is used for reducing the size of the input volume. So we just look at the example of max pooling. So see here, what is the input volume? Volume is 4 by 4. We are applying max pooling 2 by 2. Okay, so we just consider this first region. What is the maximum of this? Maximum is 6. So we just put 6 here. Okay, after that stride is 2. Stride is, it means that what is the next portion in consideration? So next portion in consideration will be 2, 4, 7, 8 when the stride is 2. Okay, what is the maximum of this? Maximum is 8. After that you come to downward 3, 2, 1, 2. What is the maximum? 3. So you just put 3 here. After that, this is 1, 0, 3, 4. So you just put 4. Okay. It was pooling. Similarly, this is another example which demonstrates the differences between max pooling and average pooling. So in max pooling, we just take the maximum. So 20 is taken. However, in case of average pooling, we first compute the average. Average of 8, 12, 12 and 20. So average is 13. What is the reason behind average pooling? In max pooling, these features 12, 12 and 8, these features might be not that much important as 20, but maybe some specific importance. Okay, but in max pooling, we just omit this. It should not like that. We should consider this, but we should give less weightage to this particular thing. In that particular case, we are having another option that is nothing but the average pooling. In average pooling, we take care of all these features, okay, and we extract the average of that particular thing. Yeah. In max pooling, what is the use of max pooling? In max pooling, we just take the dominating feature and we just ignore the non-dominating values. So here we can see this 20 is the dominating value. We just select this 20 and we extract or we remove all these values, all other values. So it is the max pooling. The last layer is dense or fully connected layer, in which it is very simple. One neuron is connected to all the neurons in the previous layer. Okay, so this animation will be clear to you, I think. What is the depth of input? Yeah, one question is there why last layer is always fully connected layers, because see, the last layer is nothing but the final classifications are there. Whether it will be binary classification, whether it will be multi-class classification. So that's why we are taking it is a fully connected layer. So it means that with the help of convolutional layer, you extract some features. So those features needs to be merged by the fully connected layer. This is the main reason behind the fully connected layer. So it might be there like some features are extracted by first convolutional layer. Then after that, some high level features are extracted by the later convolutional layer. Finally, all these features should be clubbed. And what is the task of this clubbing? Who is doing this task? This task is taken care by the fully connected layer. Another question is there. Why different filters with different sizes are used in hidden layers? So see, basically, the initial convolutional layer, we take the smaller size filter. In later convolutional layer, the size of the filter is getting increased and the number of filters is also getting increased. So because initial convolutional layers are responsible for extracting low level features and later convolutional layers are responsible for high level extraction of the features. Next question is that CNN and pooling considered as a single layer or two? No, it is a two layer. First layer is CNN layer, convolutional layer, and second layer is pooling layer. But this is the one operation, and this operation is known as convolutional operation. In convolutional operation, this pooling is considered just an optional. Okay. No, CNN and CKN is not same actually. CKN is what we can say some architectural changes are suggested in CNN, and then you can go for CKN. Okay, just look at this example. What is the width or what is the depth of input here? Depth of input. Depth of input is 3. So the depth of input is 3. It means that depth of filter will be 3. Okay. So total how many parameters are associated? 3 parameters. Okay. Before that, how many filters we are applying here? How many filters we are applying? No, no. 3 is not the correct answer. Single filter is applying. We are applying single filter, and in that single filter, 3 channels are there. Is it clear? Okay. So single filter is there. This channel, this weight matrix is for first channel. This weight matrix is for second channel. This weight matrix is for third channel. Finally, we are performing the element-wise multiplication, and all these will be summed up. And see, of this. Is it clear? You can see the values are being changed, but bias will remain same. Calculation of output volume. Before that, we have seen the calculation of output volume was that width of the input minus filter width plus our formula that we designed. But it is not the case. Some padding is also there. Like suppose if padding is there, see in the previous example, this is the padding of 0. And see, if we apply padding on this left hand side, then padding done in the right hand side also. Size of padding in left side is 1. Okay, because one column is attached, one column will be attached here. It means that if padding of 1 is applied, then width will become width plus 2. Is it clear? Suppose earlier is this 1, 2, 3, 4, 5. Earlier width is 5. If we are applying padding of 1, then one column is attached here as well as one column will be attached here. What is the updated width? Updated width will be 7. Is it clear? If padding of 2, it means that two columns are added here in the left hand side and two columns are added in the right hand side. That's why if you look at this formula, W minus F plus twice P. If P is equal to 1, it means that one column in the left hand side, one column in the right hand side. If P is equal to 2, it means that two columns in the left hand side, two columns in the right hand side. Is it clear? And it is divided by stride. If S is equal to 1, then it will be a simple formula W minus F plus twice P plus 1. But when stride is equal to 2, then we need to divide it with the help of. This is the final formula for calculation of output volume. Now we will just look at this exercise quickly. You need to answer all these questions in this exercise. So we for one input, the size of this input is 32 cross 32 cross 3. It means that it is an RGB image. So width is 32, height is also 32, and how many channels are there? 3 channels are there. First channel red, second channel green, third channel blue. Do not worry about the shape and size. Suppose this is shape, and how can you compute the size? It is nothing but how many values are there. So 32 multiplied by 32 multiplied by 3 is nothing but 3072. Okay. Now input, no parameter is associated. Simply after that we apply first convolution operation. Now in the first convolution operation, what is the filter size? What is the filter size? Yeah, size is 5 cross 5. Filter size is 5 cross 5. So what is the stride here? Stride is 1. Okay. Are we applying any padding? Padding. Okay. So what is the formula? Formula is this. Padding is equal to 0, stride is equal to 1. So simply it will be W minus F plus 1. W minus F plus 1. Okay. So W is 32. F is 32 minus 5 plus 1. So it will become 28 multiplied by 28. 28, 28. Can anybody tell from where this 8 is coming into picture? From where this 8 is coming into picture? Yes, we are applying. No, 3 channels are the wrong answer. We are applying 8 filters. See here. Just remember this example. See, what is the width of what is the depth of output here? What is the depth of output in this example? Depth of output is 2. Why? Because we are applying how many filters? Yeah, because we are applying 2 filters. So come back to this exercise. Here we get 8, and what should be the reason behind 8? We are okay. So we are applying 8 filters. So this input volume 32, 32, 3 is getting transformed to 28, 28, 8. Okay. Finally, you will multiply this 28 multiplied by 28 multiplied by 8. You will get 6 to 7. These many values are there, and this is the shape 28, 28, 8. Now you tell me how many filters are associated with one filter in this example. How many parameters are associated with one filter? How many parameters are associated with one filter? Filter size is 5 by 5. One answer is 25, 29, 10. No. Listen, you need to check the input volume on which we are applying the filter. On which volume we are applying the filter? On which volume we are applying the filter? We are applying the filter on this volume, 32,32,3. What is the depth of volume? What is the depth of this volume? Depth of this volume is 3. It means that when we are applying this filter, what will be the depth of this filter? Depth of this filter will also be 3. Okay, so first 5 cross 5 weight means first 25 weights will be for first channel. Second 25 weights will be for second channel. Third 20 weights will be for third channel. Now you tell me total how many parameters are associated with one filter? Total how many parameters are associated with one filter? Okay, 76. From where you will get the 76? So 75 weight plus 1, 75 weight plus 1 bias. 75 plus 1. This 75 plus 1 is clear to everyone? No, 125 is wrong. See, 5 cross 5 input is there. This 5 cross 5 input is applied on this 32, 32, 3. Okay. So finally, the depth is 3. So first 25 weights will be for first channel. Second 25 weights will be for second channel. Third 25 weights will be for third channel. So total 75 weights are there and one bias. So 75 plus 1. So that is nothing but 76. 76 weights are there for one filter. And how many such filters we are applying? How many such filters we are applying here in this operation? We are applying 8 filters. So total how many parameters will be associated? Total number of parameters associated will be 76 multiplied by 8. Yes, that is correct. 76 multiplied by 8 is 608. 608. Okay. If you are having any doubt, then the doubts will get clear in the convolution 2. Okay, just concentrate here. After this, we apply pool 1. Okay, so suppose pool 1 is pooling one operation and you just consider that it is a 2 by 2 pooling 2. Okay, so when it is a 2 by 2 pooling, so this 28, 28 is getting transformed to 14 cross 14. Is it clear? Yes. What is the depth of input? What is the depth of input? Depth of input is 8. What is the depth of output? Depth of output is also 8. What is the conclusion? Conclusion is that in pooling operation, depth will not get. Is it clear? Okay, question is that can we use image as label? Basically, see, we are taking these pixel values. These are the pixel values. 32 pixels with 32 pixels height and depth is 3. It is nothing but the input pixels values that is getting transformed. Okay, so this 28, 28, 8 is getting transformed to 14, 14, 8. And total how many values are there? 14 multiplied by 14 multiplied by 8, that is 1568. And as we can note that in pooling operation, parameter is associated, that's why number of parameter is 0. Okay. After that, if you apply second convolution operation, in the second convolution operation, once again you are applying the same filter, 5 cross 5 filter, stride is equal to 1. Okay, now you just compute the number of parameters. Same formula is there, W minus F plus 1. So 14 minus 5 plus 1, it is nothing but 10 cross 10. From where the 16 came into picture, suppose we are applying 16 filters. We are applying 16 filters, that's why 16 came into picture. Okay, in this first convolution operation, we are applying 8 filters. In the second convolution operation, we are applying 16 filters. Okay, so 10 multiplied by 10 multiplied by 16 is nothing but 1600. You just compute this number of parameters associated with this filter, associated with this convolution. 2. First, you check on which volume it is applied, on which volume this filter is getting applied. Yeah, 200 plus 1. So see, 5 cross 5 filter is applied. This 5 cross 5 filter is getting applied on this input. What is the depth? Depth will be 8. So first 25 weights will be for first channel. Second 25 weights will be for second channel. Third 25 weights will be for third channel. Fourth 25 weights will be for fourth channel, and so on. So total how many channels are there? 8 channels are there. So total 200 weights are there. 200 weight plus 1 bias. So total how many parameters are there? 201. This 201 for one filter. How many filters we are applying? We are applying 16 such filters. So total it will be 201 multiplied by 16. Yeah. 201 multiplied by 16 is the correct answer. So it will become 3216. Now it is clear. After that, we are applying second pooling. So this 10 cross 10 is getting transformed to 5 cross 5. Depth will remain same. Okay, 5 cross 5 cross 16 is 400. No parameter is associated here. After that, this fully connected layer is there. In layer, total how many parameters, total how many neurons are there? 120 neurons are there. As it is a fully connected layer, so these 120 neurons will be connected to all the neurons in the previous layer. And you tell me how many neurons are there in the previous layer? How many neurons will be there in the previous layer? Total 400 neurons will be there in the previous layer. So 400 neurons plus this 120 neurons. Okay, they are connected in a fully connected fashion. Okay, now you tell me how many parameters will be. So 400 will be input, 120 will be output in a fully connected fashion. So 400 multiplied by 120, that will become 48,000. Why you are getting this 48,120 here? It should be 48,000 only. Yeah, bias will be there. The output, how many neurons are there? 120 neurons are there. One bias for one neuron. How many neurons are there? 120 neurons are there. 48,000 weights plus 120 bias. It will become 48,120. Okay. After that, next fully connected layer. Next fully connected layer is 84 neurons. These 84 neurons will be connected to this input. How many neurons are there? 120 neurons. So it will become 84 multiplied by 120 plus 84. That will become 10164. Finally, the softmax layer is there, in which we are classifying it into 10 categories. Okay, so 10 neurons will, these 10 neurons will be connected to these 84 neurons in the fully connected layer. Okay, so that will become 10 multiplied by 84 plus 10, that is 850. Okay, so all these calculations are clear, I think. Okay, one question is there. If we apply 2-3 convolutional layers and then apply single pooling, yeah, we can do that because pooling is optional. Pooling is optional. We can design the architecture in a different way. That is also permissible. You can just change the filter size, you can change the stride, you can change the number of filters, okay, anything. So these many total number of parameters are there. What does it mean? These many values are there. We need to find the optimal value of each of these by applying the backpropagation algorithm, by applying the gradient descent. We need to reach the local minima. What is regularization? Okay, what is regularization? Suppose your model is getting trained in 200 epoch, in 300 epoch. So what does it mean? You just try to overfit the data. It means that the complexity of the model is getting increased. Okay, so this should not happen because we do not want that. Why we do not want that? Because if the model is getting trained on the data to a very close proximity, it means that it is capturing the in the data itself. So it is not able to generalize the data on which it has not seen before. Okay, what is our aim? Our aim is that we want to construct a model such that it will minimize the error as well as it should perform well on the testing data. Testing data is that data to which the model has not seen before. Okay, so two aims are there. First aim to minimize the error, training error, and second thing is that we want to generalize the model. Okay, if you perform the training to a significant extent, it means that you are trying to reduce the training error. Okay, so training error is getting minimized. When the training error is getting minimized at certain point of time, after that if you train the model further, it is becoming overfitting. It means that when it is not able to generalize to the data, or to the more specifically to testing data, that we do not want. That's why regularization came into picture. In regularization, there are different types of regularization like L1, L2, dropout. Okay, so depending on the application requirement or the application nature, we can use the regularization. Regularization is nothing but the generalizing the model to the data it has not seen before. Another question is that how do we decide the size of the filter for each convolutional layer? So generally we can see here the filter size is 5 cross 5, here the filter size is 5 cross 5. You can just change the filter size also. We can take filter size 8 cross 8, you can take filter size 8 cross 8. We just look at one example here. See this. Look at this image. Okay. So yeah, it is experimentation based. First of all, you need to look at very closely. Like all these are dog images. This is dog image, this is also dog image, and this is also dog image. Okay. Here we can see this dog image is capturing the entire area of the image. This dog image is very small. It means that if all images are like this, then smaller filter will be beneficial in this case. Okay. However, if the dog images are like this, in this case the filter size should be large. If the filter size is large, then only it will be able to capture the face of this dog. Am I made myself clear? Another question is that how pooling and convolutional is different in physical significance point of view. So convolution is feature extraction and pooling is extraction of dominating features. Okay, just do not confuse between this. Convolution is extraction of features, pooling is extraction of dominating features. What is dominating features? Dominating features is nothing but that is taking care or that is taking part in the final. Okay, so these are the generalization of convolution and pooling. As I am running out of time, I just show the code of this. How can we write for this? Yes, is the screen visible?
Yes, sir.
So see this. We will just look at how the model is defined. So it is just an example of handwritten digit recognition. So these are the handwritten digits. We just want to construct a CNN for this handwritten digit classification. Okay. So first we load the data, training data, testing data. Okay. Suppose this is the final pixel values and it is nothing but this 5. Okay. We do not bother about this. Actually, we just look at the model structure. So see, this is the model structure. We define the sequential model. In the first sequential model, you add the first layer. Okay, so you add first layer, model dot add. Which layer you are using? you are applying convolutional 2D. It means that filter you are applying. Okay. It is a GitHub code that is already available. You can just download this code and you can have a execution of this also. Okay, no need to install anything. You can just go right, Google Colab, and then you can run this code. Okay, just look at this. Here we are applying this filter, convolutional 2D. Now see how many parameters are associated or how many features, how many characteristics are there with one filter. We need to define the filter size. Okay, so here we can see the kernel size is 5. It means that we are applying filter of 5 cross 5. Next, we need to define how many filters are there. So we can see filter is equal to 8. It means that how many filters we are applying? We are applying 8 filters. We need to define stride. Stride is equal to 1. We need to define the activation function. So here we can define the activation function is equal to tf.keros.activation.relu. It means that relu is used as an activation function. And the next thing is that how the weights are initialized. So initializer dot this method is called for the initialization of weights. Is it clear? So this is the first convolution operation. So after this convolution operation, we can apply pooling. So this is the max pool 2D. We can apply cross to pooling, stride 2. Okay. After that, we are applying another convolution operation. So this is the second convolution operation in which we are applying once again 5 cross 5 filter, 16 filters are applied, and then one stride is there. So activation function, then model dot add, then once again pooling. Okay. After applying two convolutional layer, we just add the fully connected layer. Okay. So here we can see it is a dense layer. Okay. How many neurons will be there? Unit is equal to 128. It means that 128 neurons. Okay. Finally, one question was there, like what is the regularization? So here we can see we are applying regularization for generalizing the model well on the testing data. So 20% dropout is used here. So dropout is equal to 0.2. Dropout is a very famous type of regularization. We are using dropout, and finally some more fully connected layers are there. If your output belongs to 10 categories, like category 1 to category 10, it means that total how many neurons will be there in the output category? Unit is equal to 10. Okay, then we are applying softmax, and then finally this is the kernel initialization. So this is the model structure. Three things are there. First thing, define the model. Second thing, compile the model. Third thing, fit the model, and finally you need to fit the model on the testing data. So this is the 4 steps are there for the synthesization or for the construction of any CNN architecture. Actually, some more slides were there, but I could not cover the slides. If the question is there, then we can look at those questions or those queries. I think parameter calculation is clear to everyone. Okay, I am sharing my mail ID. If you are having any doubt, then we can discuss via mail, or you can connect via LinkedIn also.
So thank you, Toshib sir. Thank good presentation and the good examples. So I request the participant that the mail is already sent to you with respect to give the exam. So you can open your mails and you can start giving the MCQ exam. Meanwhile, regarding attendance, I'm going to share the attendance link in the next session. So
sir.
best of luck to everyone. Please
Hello.
do the exam because that is also the part of Atal workshop.
Hello, sir.
Yes.